talk session. So today topic is on Azure Network Services. So this topic is mostly for developers. I think might not have been exposed much. Recently in our project also we had to go through some of the such component for some requirements, and I felt that it interesting, and I think you can also provide your feedback, your input. So people who have already engaged in this area, please share experience. All right, so the agenda of this session, first I'm going to take you through what is Azure Network Services, just an overview, and what components are in that under that category. And in this session, I'm specifically focusing on one particular component that is called Azure Application Gateway. Then we'll talk about security, especially for enterprise level application, how we can, what are the common industrial used best practices or tools available for our applications. So under that, web application firewall, DDoS attacks, and the protection strategies. And I will use a demo. I will do a demo on application gateway. All right. So what is Azure Network Service? So Azure Network Service consists with mainly four subcategories. The first one is the connectivity service. Connectivity service basically connect your resources, Azure resources as well as on-premises resources. So for example, you can say VNet, virtual WAN, VPN gateway, Azure DNS. And other one is application protection services, which basically protects your application. If you take WAF stands for web application firewall, DDoS protection service, and Azure firewall. Application delivery service, basically this to deliver your application using Azure Network, such as Azure CDN, front door, and application gateway, which I'm going to talk in this session. And the last one is network monitoring, basically to monitor your network resources. So for that, we have Azure Monitor. I think some of the projects actively use this tool, and another one called Network Watcher. Okay, so let's see. So in this session, as I mentioned earlier, so we are going to basically focus on application gateway. But as you can see in the application delivery service, under application delivery service, so there is another component called front door, which has similar capabilities as application gateway. At the end of the session, I will basically summarize that so you will understand it better. Okay, so what is application gateway? So application gateway. So basically, this is an application delivery service, as you noted in the previous slide, and which so this is basically a layer 7 load balancing and security and web application firewall function, which provides the web facility. So the most important thing that you have noted here is about the load balancing part, and the layer which it operates in the OSI level. I'm pretty sure you can remember the OSI level, which starting from physical layer, data layer, like that. I will share you that if you can't remember the chart. So what is meant by a layer 7 load balancing? Now, if you take a traditional load balancer, that actually operates in layer 4. Okay, so let me show you with this slide. Now you can see layer 4 means transport layer. So that means so the traditional load balancers, for example, if I take Azure load balancers, they inspect few packets, TCP or UDP packets, to determine probably for routing, to make such decisions. Though they analyze the IP address or probably the port number. Okay. However, layer 7 now, actually the low layers 4 are these actually rely on hardware and probably proprietary softwares implemented in like integrated into this hardware. Those days the application or software components were not that powerful. But now the layer 7 load balancers are available, like application gateway, where they also analyze. Actually, this operates in the application, so in the application layer. So if you can see, this operates in the application layer, which means basically you are reading the data. Okay, so that means it reads the URL, the message content, port number, the IP address, even the information in the cookie. So it can access wide variety of information in order to make routing or load balancing decisions. So that's the important difference. That's the vital difference between an Azure Application Gateway and a traditional load balancer. Okay, so if you talk about Azure Application Gateway, actually it consists with mainly two tiers, V1 tier and V2 tier. Of course, V1 tier came before V2. There are significant differences in these layers in addition to the WF support. So in my demonstration, I'm going to show you how to set up a application gateway, because even that few steps, it's sort of important. So you can understand what exactly what I meant by this V1 and V2. But just to mention you about the V2 features, V2 supports auto scaling, where that you can say you can start with a minimum number of units, and you can give a maximum number of units, right? So I think all of us are familiar that kind of a structure. That means when you have huge traffic to your application, based on the traffic, it will dynamically grow the number of application gateways. Okay, and other one is zone redundancy. Now think that I mean, if you take architecture, right? So you have to understand that most of the time we think of the application itself, right? So we write the source code and we deploy, but there are much more component or pieces which work together to deliver a secure product. Okay, so in that case, if you take application gateway, actually it sits in front of your architecture. Okay, so if it sits front and if it faces the traffic, okay, it needs to handle all the traffic properly. Otherwise, the traffic will not even reach your application, right? So that's why it's important about auto scaling and the zone redundancy. Now let's say within a region, now application gateway only operates in regional level. Okay, it's not a global product. So that's I'm just highlighting. If you can remember, I mentioned about Azure front door, right? So front door and application gateway, the two main difference is that front door is a global resource. It operates in the global layer. However, application gateway is a regional resource. So within the region, if there is any sort of a failure, it have zones. So if one zone has some sort of a failure, other zones will act, and basically your application will perform without any issues. Static VIP. Now in application gateway V1, you don't have the static. I'm talking about the public IP address, but it was dynamic. It will not lose even after you start the services, which means you basically get the same IP address in V1. But in static VIPs, your application gateway is always will not change the IP address during its life cycle. So this is a main achievement in the V1 V2 application gateway. So when I'm creating the application gateway, you can see that I have to select the IP addresses. So there you can see the difference when I select V1 and V2. Okay, right. And other thing is about the header rewrite, which means that you can modify the response headers. Basically, you can change the cache controls, things like that. basically modifying the HTTP headers. Okay, so these are the features that V1 version did not support. All right, so now let's see. Okay, sorry, another thing is, of course, V1 V2 has better performance than V1. So basically it's an improvement from V1 to V2. Okay, so let me go to the next slide. Please, if you feel if you don't understand anything, please feel free to ask any question. Okay, right. Now, first of all, you have to know what. So this is the structure or the main component, the building blocks of an application application gateway. Now, if you see starting from the browser, this is basically belongs to the external site. Now, there is always a front-end IP which sits in front to accept whatever the traffic. And there is another component called HTTP listeners, which basically listens to your HTTP traffic, and it will basically evaluate rules. Okay, it evaluates rules, and it has some backend pools where your virtual machines, web applications, public IPs, NICs, which means network identification cards. So everything, it will be forwarded based on these rules. Okay, so that this is what happens when an application, web application gateway receives traffic. So goes to the listener, and thereafter there is a HTTP setting. That setting belongs to the backend server. And there are rules associated with this setting. Rules will be evaluated and traffic will be routed to the respective backend pool. So each and every component will be discussed in the next few slides. Okay. Go to the first components. As you can see, this front-end IP is the first component. So this is the IP address associated with the application gateway. So when you are creating an application gateway, you will be able to see that you have to basically get that IP address component. So it's another Azure component, right? Which gives you a static public IP address. All right, it can be static public, or it could be private IP address, or it could be dynamic IP private or dynamic public address. All right. And V2 SKU, so the V2 is SKU means a stock keeping unit, right? Yeah, V2 SKU you can configure to support both either static internal or public IP address or static public IP address. So if it makes confuse, don't worry. In the demo, I can show you that how we are going to configure these the IP addresses. But just note down the last one. In the V1, it only supports static or dynamic internal IP addresses. Okay, but not static public IP addresses. As I said in the earlier slide, always the dynamic public IP addresses were supported in V1 SKU. However, in V2 SKU, it supports public IP addresses. Okay. Now, now we know that IP addresses are basically used to, for DNS resolving, where you can reach the web application. Right now, so you might think, why do you need to have a private IP address? Now, these application gateways are not just public facing. It will also act as internal load balancer. Now, just think that this application gateway is like a square, right? Your components will reside within this square, right? It's sort of a boundary, and it will work like a network, right? So in that network, you have servers, so you have internal request. So for that internal request, it will do the load balancing. So for that, it need to have a private IP address. It's not necessary to have a public IP address unless someone access your application gateway from outside. Okay. Other one is listeners. Again, I go back to the slide. So you can see this is the second component. Okay. So listener basically listen to request, simple as that, right? So it listen to a port under given HTTP pattern. So HTTP pattern in the sense it could be HTTP, HTTPS, or HTTP2 protocol, and it triggers whatever the rules. So this can configure multiple listeners, so that your application gateway can have multiple listeners, not a problem. As I said, supported protocols are these, including WebSocket, right? So I think in WebSockets, I think these are HTTP. I think you are already familiar with HTTP and HTTPS, right? So what is HTTP2? So if you guys are familiar, do you have any idea what's HTTP2? Anyone?
So it's the newer version of HTTP specification, right? So as I remember, we by default we use HTTP 1.1,
Yes.
and this is the version 2 of. I don't know what are the differences or improvements.
Yes. Okay, that's correct, Ravin. So it's basically the next version of HTTP 1.1. Now it has a lot of performance improvements. That's the main reason HTTP 2 protocol was released. And I wish the next slide actually contains those features so that you can understand. So just to tell you this again, these are the protocols. WebSocket. So basically we use like SignalR for real-time communication, right? So that means out of the box, WebSocket supports by the application gateway. Okay.
So
Uh, yes.
Hiran, just one thing regarding this HTTP2. So
Mm-hmm.
this automatically applies to HTTPS as well, right? I mean,
Correct.
secure or not secure, it's like that version 2 is there for both, right?
I think so, Ravin. To be honestly, I never gave enough thought of HTTP for the HTTPS, but I think it should be because anyway HTTPS is the TLS, transport layer security.
Yes,
So for
yes,
definitely HTTP2 it should support.
yes.
Yeah, because it's actually widely used now. Because major browsers already started supporting this version.
Mhm.
Okay, now what you have to understand is that now, as I said, if you draw a line, okay, so from the left hand side is the public side. So your request can come from 1.2 HTTP2, sorry, HTTP2. However, the application gateway will not use another call to make a call, it's not going to make initiate another HTTP2 call to the backend servers, right? So it will only make HTTP 1.1 call. So that's how it behaves. So there are two main types of listeners, main types of listeners. So they are as a basic listener and multi-site listener. Basic listener is, so as you can understand, it's very simple listener where it you just listen to a URL or HTTP request and just redirect the traffic to the backend server. That's simple as that. However, multi-site is a bit differs, where your application gateway can listen to multiple domains. Now, for example, you can see contoso.com and fabricum.com. So now what they have done was, probably, I think Hedu can guide me if I'm wrong. So they might have added correct address, a record, where when someone types contoso.com to redirect the traffic to the public IP address of the application gateway, like similar to the fabricam.com. So what happens is, in the application gateway level, you can now listen, because now you are listening to the same port, right? You are just listening in the application gateway. You are just listening to the same port, HTTP and HTTP. So what the differs here is the domain, because you have multiple domains. So for Contoso, you can write a different listener, basically to redirect the traffic to the Contoso pool, and Fabricum for the Fabricum pool, like that. So I will show you how to do that. But in my demo, I will just show you the initial step, because I don't have these multiple domain support. I didn't have a domain controller, so I couldn't do that. But I will explain that during the demo. Okay.
Yeah, so, so why is the listener using only HTTP 1.1 for the communicating with the right side thing? So
Yeah,
is that
Daniel. So
different?
Yes, so that is not clear. But that's what they have mentioned in their documentation, is that they don't use HTTP2 for the backend communication. They haven't mentioned why they don't use it.
So
Okay.
HTTP2 is
Yes.
the most more performant one, more efficient one. So why they are not? Yes, that's okay.
Yeah, Tharika, I think more efficiency comes now. Yeah, you can argue in that way as well. Uh, yeah, of course. When you see the HTTP2 features, you can see it has a lot of benefits performance-wise. But probably the application gateway might have, it's a developed a long time back. Because these application gateways or these components, like, you won't believe, the front door, okay, Azure front door, actually this was developed and used by Microsoft like 5 or 7 years back, and they put it to the market after they really use that. So you can see that probably the application gateway also the same. Probably their core might have written long time back, but after this new HTTP 2.0 arrives, probably they might change later, but not sure exactly why they are not supporting it. All right, so let's go to the other one. Just to highlight, I found this really interesting HTTP2 protocol. If I think someone can just take entire session on this protocol. So it's just multiplexing, basically, which means they just use one TCP channel and issue many requests to minimize the cost, rather than creating multiple TCP connections, which mostly used in 1.1. And other one is called header compression. Just to it compress the header to reduce the wire bandwidth, the size, so which significantly reduces the header size. And stream dependency, so the client can define which resources in which priority. You can indicate these resources should be in this particular order. Just to tell you about this brief history of HTTP2 protocol. So this was developed by Google in 2009. This the project called SPDY. So they actually wanted to overcome the issues in 1.1. So that's why they developed this protocol, and they even lab tested that, and it was very success. They increased the performance by 50%. So that's later they developed their Chrome browser, and then Firefox. Likewise, major browsers started supporting this. Okay, this might not relevant to our application gateway, just highlighted. Okay, the next thing called HTTP setting. Now, so the HTTP setting actually it contains the information of the backend server. For example, what's the port number? What's the protocol that I should address? Like that. And also determine whether, okay, this is a bit important, where you determine whether your traffic from backend server, so from application gateway to the backend server, is encrypted or plain text or unencrypted. So that is also defined now. There are two terms that call. One is called TLS termination. TLS termination means that you terminate the TLS secure communication from front end to the application gateway. However, thereafter it goes plain text, right? So it has a lot of benefits, because the backend servers, they don't need to decrypt the TLS, because nowadays, you know that due to security vulnerabilities, security issues, the key sizes are very large, right? In order to decrypt the traffic, you need, there are a lot, it consumes CPU, a lot of CPU. But now see, now the application has to do this decryption as well as need to serve your application. So it's unnecessary work for the application. Now if someone else who specialize in this area does that, it can that task get offloaded from the application. So that's one advantage of this, but I will show you about that as well. And cookie based session affinity, so that means that you can always it will include a session to the request, so that it can always send to the same server or same virtual machine in that application server pool. Okay. And connection draining. Connection draining means that now take an example where you have a backend servers, and let's say 5 servers sits in that backend. Okay, this farm. Let's say one had an unhealthy status due to some reason. Now what happens is, if the application gateway tries to redirect traffic to that particular unhealthy instance, your connection might not, the client might not get a proper response. So in order to avoid that, it does a thing called probes, health probes. Basically it sends like health probes, whatever the time, within the given time duration, and if it doesn't get any response from the server, it determines that okay, this is an unhealthy instance and I should basically remove. Even though it removes, then what happens is it actually does not send any request to those unhealthy machines. I will show you that in the next slide. I have some sort of a graphic so that you can understand properly. So this is what I mentioned about probes, health probes, to monitor the backend health. Okay. Now let's talk about the backend pools. A very simple thing. It's just a combination of backend servers. It could be NICs, virtual machines, FQDN, which means fully qualified domain names, public or internal IP addresses, or it could be Azure Application Services. Okay, health probes. This monitors the health. I think this is what I just mentioned. So you can basically monitor the health of the monitor the health of the backend service. So you can see now the application gateway keeps on sending probes. So probes are nothing special, just HTTP request, simple as that. Because you mentioned that you should always communicate with the backend server using whatever the protocol and the port. So it just use that procedure to communicate. And see, now this one is unhealthy, that's why it get 500. Thereafter it does not send any request. But let's say once this guy become recover, but still this guy always send are you there, like that. So if it get a proper signal, then it starts sending the request back to that VM. Okay, so I talked about the few one important thing is about the TLS termination. Now TLS termination means that as I said earlier, you basically decrypt the content and you just send the plain text to the backend servers, right? So it's like this. You got the request data, and here thereafter it's plain text. Now, so this improved the performance, as I said earlier. So it better utilization of backend servers, right? So it's very CPU intensive. So the backend server offload with that kind of CPU intensive operations. Intelligent routing. Now, because it decrypts the data, it has access to all this information, so it can do whatever the intelligent routing. And certificate management, you can centralize certificate management. So now the backend servers, they don't need any certificates, right? So because only your application gateway needs to have the SSL certificates. That's centralized. Okay, end-to-end. So other part, the opposite of this concept is the end-to-end encryption, which means you communicate with the backend servers with TLS encrypted on. Now, why do you think that you need that kind of? I told you earlier that it has a lot of performance benefit. Then why are we doing that? Because of course, some organization has compliance, right? Now, for example, in our project, when actually I talked to one of their, so they mentioned that you can't trust even the people in working in Microsoft. So that kind of, if you want to impose that kind of compliance, of course you have to go for end-to-end encryption. So what happens here is, again, it terminates the TLS communication and decrypts whatever the data, right? Thereafter, it actually, first of all, for you to do this end-to-end TLS encryption, you need to have the certificate of the of that target application server in your side, because now you are going to re-encrypt the data, and you are again initializing a new TLS connection to the backend server. So basically, you are re-encrypting the data with the public key certificate before you transmitting the request to the backend server. So these are the two concepts that we are using. So I don't have this end-to-end TLS encryption for the demo because I don't have any sort of certificates. Okay, session affinity I mentioned already. because you want to keep the same session sticky we call sticky sessions. I think we are all of us are familiar with these sticky sessions. Yeah. Okay, now the other important thing is about the WAF, which is Web Application Firewall in the gateway. Now, Microsoft Azure, they have Web Application Firewall. So I will tell you what is a Windows Web Application Firewall in the next slide. Now, they actually, yeah, I think this is the slide that I want to highlight. Now, Application Gateway is where your front, it sits in front, and whatever the traffic that comes to your network, basically WAF analyze the packets, and it has policies, a set of defined policies, and it checks whether these are legitimate requests. So basically, WAFs prevent some common attacks like SQL injection, cross-site forgery, cross-site scripting, and more importantly, bot protection, because 20% of the traffic today, global traffic, are from bots. So they actually, you won't understand. They are even for me, first time when I heard that some of the attacking types, they are like sometimes even your web application firewall, it doesn't make any sense, because because in order to handle whatever the threats, the traffic first of all need to travel your web application firewall, right? But there are some attacks where your entire path get basically filled with traffic. No one can even reach your no one can even use your path to reach your application. So that means no one will even reach your web application gateway. So that these kind of, because of these attacks, they don't attack your application, they just attack your paths. Okay. So now WAF implementations are two types. One is called network based, which involves hardware, and they are very expensive. And the other one is cloud based, like Microsoft Web Application Firewall, Azure Web Application Firewall. They are actually third-party developers, and they are basically, it's black box to us. We don't know, we don't see what happens there. I'm not sure for like enterprise applications, like for banks, whether we should use cloud-based application. I think if you take Sri Lankan banks, they are investing a lot for this network-based hardware web application based on the hardware. Right. So just to show some interesting facts about WAFs, you can see the leaders. This is called Gartner Magic Quadrant for 2019 for web application firewalls. You can see the leaders. So have you heard about this product Akamai? So this is one of the leading web application firewall. One of my friend who told me that this is the Facebook that they use Akamai firewall, and they have also CDNs available worldwide. And you can see Microsoft, where Microsoft sits. It's actually this is called I think you can't see this. This is like niche players, challengers. Sorry, this side called challengers. Sorry, challengers are here. I'm sorry. The leaders are Akamai and all these things. And Barracuda is another challenger. Microsoft, they are, I think, niche players. Yes. And basically, I'm totally new to this. Just thought that it will be interesting to share with you. Right. Okay. So here again, this actually provides protection. Web application firewalls. Azure Web Application Firewall is provides centralized protection of to your application. Now, how can we deploy a WAF? So Azure, of course, supports web application deployment in front door, or if you are using Application Gateway, or if you are using Azure Content Delivery, CDN. So these are the only three components that you can deploy a WAF at the moment. And it's based on core rule set of OAPS 3.1, 3.0, and 2.2.9. But you have to you could only select one of these. Okay, and also Microsoft Bot Manager rule set. I will show you all of these, how you can select and how you can configure a WAF in Application Gateway. Yes, so a bot mitigation rule set. So it basically how bot mitigation rule set happen is basically it remembers these bad IP addresses And Microsoft Microsoft has a global network, so they actually record all these interactions and make sure that any traffic that arrives from these networks or IP addresses, they basically absorb. Okay, DDoS attack. What is a DDoS attack? So basically, it's going to exhaust your application resources, and it making your application unavailable to the legitimate users. So I just mentioned earlier. I just mentioned about this attack where no one can reach your web application. So this is called volumetric. So there are different types of DDoS attacks. So the first one is a volumetric attack. It's basically flood your network layer with a lot of legitimate traffic, and not a single user can reach your application. That's simple as that. Probably they might not attack your web application firewall or web application. It just flood with traffic. And protocol attacks. Some of these things are also new to me. I didn't go deep into these attacks. And resource layer attacks. So resource layer attacks, of course, will be covered by web application firewall. So we don't need to worry about it. But for this DDoS attack, Microsoft has a different service called DDoS service, DDoS attack service. So that will protect your resources from such attacks.
Hiran,
Yes.
Hiran, these resource layer attacks, are they the ones that we learn in the university, like the SQL injection,
Exactly.
cookie cross-site scripting?
Yes.
Those
100%.
things, right?
Yes. Now I think it's good that we came to the demo. Now in the first part, I will show you how to set up an application gateway, and in the second one, let's see. Okay, so how we can set up a very basic scenario where you set up a basic listener, and this will have the TLS termination, and you will reach a site. Okay, so let's go to the. Can you see my screen? Can you guys see? Okay, right. Now, okay. Now, for this demo, I actually created a free trial account for myself, and I had like $200 resources. So just use the minimum resources. Okay, so now I have created this. Okay, first demo part, as I said, this is going to be creating a new application gateway. Okay, so how we are going to create? Let's say gateway. Application gateway. Okay, right. Okay, so the first step here, you can see now, this is a simple thing. You just select your resources, and let's say demo test. And my region is South India. Standard. Okay, now you remember I told you about the tiers. Standard V2. So these are the tiers: standard and standard B. This is V1 layer, V2 tier, and WAF. WAF actually comes so that you can say that for standard WAF V1. This is standard V2, and this is the equivalent of WAF enabled application gateway. All right. So you can see that if you select these tiers, the UI change. See the instance count, because in the standard tier V1, as I said, it's not auto scalable, right? So you have to give the instance number of instance, how to handle the traffic, and also it provides you to select the SKU size, small, medium. Small, I think, is for developers. This kind of a thing. By default, HTTP2 is deeper, so you can enable it. Now, for this demo, I will use standard WAF v2 enabled one, and you can see now it's sort of changed. Enable auto scaling. So you have the option. So I said yes. So you minimum, I would say 10 to and go for 10. Now what? Then ask. So you want to enable the firewall? Yes, I want to enable the firewall and firewall mode. So there are two modes: detection mode and prevention. Detection means that it detects and logs, and it actually let the threat to access your application. Prevention means that it actually detects, logs, but does not allow to access your application. Oh, what happened? something. So I will use so this with this very basic thing, and this is very important. See, you cannot proceed without creating a virtual network. As I said earlier, so you can operate this application gateway in as a internal load balancer as well, right? So that means definitely it works in a virtual network. So virtual network is like it's like your own network at the cloud. Right now, especially when we are talking here, we are talking about the Azure. Okay, so everything is secured within that boundary. Now I have created a virtual network for my application. Now one thing you have to understand is that you can now actually I have already created an application gateway. It's there. You see, now I can use this virtual network to the new application gateway that I'm creating. The reason, you can assign multiple application gateways to the same virtual network, right? But ensure that you are assigning to the same subnet. So subnet is that, like, logically you are giving IP address ranges. So for this, which means I'm using this range for the application gateway. Okay, now I'm going to the next step. So you can see the IP address types, public, private, or both. Because I choose V2, I have this option. Actually, I for my demo, I used to create public one, and you need to create a public IP component. See, actually, I created one, but this one actually already associated with my already created one. Therefore, I can't associate. So this is it. Other than that, these tabs are very basic things that anyway I'm going to cover during the demo. So I will revert back. I hope you understood the creation part. So these are the most important. Even for very first time I got confused, but these are the things that you have to configure. Okay, now let's go back to my resource, and I'm going to do the first demo on creating a web application, right? So now and letting through pass whatever the traffic to be passed through the application gateway. So for that I have created a storage. So this storage, I enabled static websites. Static website means that if you, I think almost you guys are heard about this. Now we are actually doing single page applications, right? It doesn't do any like ASP.NET request pipeline. You don't need to have a server side logics to just to serve static content. So you can simply use this storage, and you can simply enable static website. So that's an advantage where you don't need to have an app service plan. See, static website. So you have to enable the static website. I think Ravin already familiar. I think me and I we do discuss about this. So once you enable, it provides you a URL. Okay, now what I'm trying to do here is just to show you what I hosted in this site. So this is the simple site that I hosted. It just delivered me the site. Now what I'm trying to do is I'm going to prevent access to this site from rest of the parts. Now for that I say that allow access only from this particular virtual network. So you can see that I actually, because I earlier created, you can see that. Otherwise you can just create like this. So you have to select the virtual network and subnet. So I once I configure.
Hiran, just check your screen share. Okay, it's fine.
Oh, can you see? Can you see?
Yeah, now we can see the browser window. Yeah.
How about now? Can you see this incognito mode?
Yes.
Okay. Right. Let's see why it's not selected networks. Probably it might get cache or. No. Okay. Now you can see the requested content does not, I think because of the caching, whatever the thing, I was able to access. Now I can't access because I restrict the access. Now what I'm trying to do is I'm going to configure my application gateway to communicate on behalf of me, on behalf of the traffic that I'm receiving for this domain. Now, the first thing first, let's go to the application gateway. This is my existing application gateway. So first thing that I'm saying that, okay, I need to have a listener. I'm listening to the traffic. So these listeners are actually I created at the very first time. There has to be a listener, very basic thing, listener, setting, rules. There has to be minimum one in order to create a application gateway. So because of that I created. Now I'm going to create a new one. Let's say front end. I'm just defining my listener name as front end. You can give any name, front end listener. Okay, and I'm telling that I'm listening to this. This is my public IP, and I'm listening to this port, and this is my HTTP. I'm using the protocol, listening to this protocol, and I'm using listener type basic. Okay, I added that. Okay, now let's see now what else needs to be done. Now I need to have a HTTP setting. Okay, so there's no proper order. You can create probes or whatever thing, but I just choose this path because I'm sort of familiar with this path. So HTTP setting, again, just to remind you, this is where you keep your settings to the backend server. Okay, so you can say front end server setting. So I'm telling that, okay, I am calling the backend server using the backend HTTP protocol. If you want, you can enable this cookie-based affinity. See, in that case, it gives you, this is the default name. You can change the name if you want. And connection draining. Do you want to support connection draining, which means a drain timeout? Let's say whatever the 60 second. And request timeout is like basically for 20 seconds you wait, you make a call and you wait 20 seconds, and if you don't get, you make it, you basically drain that particular instance. But in here, of course, we have only one instance and one pool, right? So basically you're out of the pool like that. I don't need this. Yeah, okay, so just how this okay, now you have to understand that host name. Now when the application gateway receives a call from the outside, it actually just forward with the default setting it received from the original request. So the host name probably will have the whatever the DNS name of the application gateway. But if you want to modify it, because now you know there are instances, components like Azure API Manager, right? APIM actually does rely on the host header a lot, right? Because it can have multiple API hosted. So for that to reroute the traffic to the relevant API, it needs to know the host. Therefore, you can say, okay, I'm going to override the host, and I'm going to tell what's the host. So now here I'm going to tell that this is my host because this is the URL that I got from the storage, and it asks whether you need to have a custom probe. Again, just to remind, probe is just a health checker for the backend server. At the moment, I would say yes, but I don't have a. I just created 2 probes for my demo, but the one that I'm targeting is not here, so I would say no at the moment, and I will create. Okay, now let's go and create a probe. Just this is for the health checking. Let's say front end probe. Front end probe, it uses HTTP, so this is how it communicates to the server, backend server, using HTTP : this URL, and we'll just accept these default settings, and you see the path. If you want, you can just say index.html because I have that, or you can just say root. That's fine. And I just accept these default settings as it is. An unhealthy threshold, that like it gives 3 shots and see if it succeeds or not to make a judgment. And let's say HTTP setting. So I have a front-end HTTP setting, so I can select that one here. And see, you can do a test whether the backend is healthy. But this health will not work. The reason is your HTTP setting is not associated with the backend pool. So for that, you need to have a backend pool. So let me untick this and just simply add this. Okay, and now let's go to the backend pools. Right. So backend pool, again reminding, this is just your this is the place that contains your backend service. Right. Now let's say I am confused, but just to tell you that front end means my UI, web UI, backend pool. Right now, it asks whether you need to targets or not. Add without target, no, I want to add a target. And what's your target? So I'm going to give a FQDN, which means a fully qualified domain name. So I know the domain name here. This is my domain name, and I can simply add. Right. It get add. All right. So it's there. Now let's go and see whether I can do a health probe. So this is my front-end probe. Can I test now? Let's see. No, still I can't. It says that you need to associate with the backend pool. Even though I associate with the backend pool, actually what it meant is that you need to associate with the rule. It's sort of misleading. Okay, now let me go to the rule, and I'm going to create a rule. So this is important, which I'm going to cover a next slide, next demo, basically in this routing area. As I said, application gateway is basically routing, right? Now, how it routes, actually it follows the rules that is being given to him. Now here I'm just giving a very simple, for this initial demo, we will use a simple rule. Okay, I will give a name as front end rule. Okay, and listener is front end listener, and then it tells me, okay, select the backend targets. What's your target? So you can see, just give here, you can focus here for target type, whether this is a pool or a redirection. I will come to the redirection. This is an important thing. So here I'm going to select a backend pool, is my front end backend pool, and setting is a front end server setting. Okay, so there will be no path based routing here. That will be covered in the next one. So I will this is a very basic one. I will simply add this one. Okay, and while it gets saved, now let's go back to the probe and let's try to check whether our our backend is healthy. Now I'm going to make a call, test call. Let's see. It's success. Even in my previous attempts, there were instances, most of the instances at the very beginning, everything gave faulty statuses. Okay, now that means our backend service sort of reachable. Now, first of all, we need to know what is our DNS. For that, you can go to the overview of the application gateway, and you can see the front-end public IP address. So this is the IP address. So you can use the IP, or you can give the domain name. So I actually created the DNS entry for that. So this is my DNS name. I'm just copying, and now let's see if I can reach. See, now you can see that I was able to access the this thing, right? Now, what's the protocol that I used? This is simple HTTP protocol, but nowadays no one uses HTTP because of security issues. So then now let's try to use HTTPS, and let's make sure that no one else try to communicate us using HTTP. All right. For that, what we need to do is we need to create another HTTP setting. So this time I'm going to tell that I'm listening to HTTPS. So this is secure front setting. And okay, so now for this actually demo, I created my own certificate. Certificate Sorry, I think I think I did the wrong thing. First, I will approach this using the listener. This is where it listens to the front end request. Sorry, because it was on the top. I used this. Okay, listener is my secure front end listener. Front end listener. So this is again the public IP and the port 443 because it's the HTTPS. Port 443 is not valid for protocol HTTP. Okay, now I'm going to select a certificate. Actually, I created the self-signed, I did a self-signed certificate. That's why I uploaded here, and you can see that my cert. Now this is going to be a basic one again, same thing, no difference, just the HTTPS thing. Do we need to have a setting, HTTP setting? No, right? Because we are trying to reach our backend storage anyway using unencrypted, right? So basically, you don't need to have this front end. Sorry, the one that I think I didn't create that. I tried to create a HTTP setting earlier, so you don't need to have, because anyway you are using HTTP to communicate to your backend server. Right now, now for that, now I need to go to the rule, and now we need to create a new rule. For that, I'm telling that okay, let's say secure route, and my listener is secure front-end listener, and the backend target is this pool, and HTTP setting I can use the base front-end server setting. Right, simple as that. And I'm going now. We can communicate using HTTP. We should be able to. Now let's try that. So here it's copy the URL and type HTTPS. Still saving. I think in this tier base, usually it's really slow. It will take some time. That's why you will not be able to load the site using 443 HTTPS. Okay, in the meantime, once a while it gets saved, just to ask, I think there are projects, are there any projects that use application gateways? I think a Meter project, I think they use. Am I correct? From Meter team?
In Droppoint,
we used to, but I think it's disabled.
Sorry, you think?
Chandra, it is being used in the production environment, right?
Hetu, now I think it's been disabled in the production environment, but I am not really sure on that. We did have it, and after a while it was disabled. I'm not sure whether that's back up. Need to check.
Okay, I think Priya said, Priya, you are using front door. Is that correct? Is it Priya who said the?
In Droppoint, we use.
Sorry. Okay, so you are using what you are using in Droppoint?
In application gateways, we have set up.
Okay. So do you use this kind of a setup or like any advanced configurations?
Yeah, we have a VNet and not a VNet actually. Yes, we have a separate DNS provider. So we are in the DNS provider. We are like targeting it to the gateway, application gateway, and within the gateway we have defined rules and listeners for each and every web application.
Okay, all right, that's good.
So in Charmika, so in your case, I remember when Priya was also configuring this, there was your backend pools were some VMs, right?
No, I'm talking about the past solution.
Ah, right. Okay, even in that you have used this to protect the app services.
Yes.
Mm-hmm.
In the production environment, the resources, app services are not directly accessible.
Okay, good.
Okay, so now we can, I just use HTTPS. So I think now I can access this one, but still I can use HTTP to communicate as well. All right, so that's not been, blocked. So what we can do is we can simply do a redirection. So what we are going to do here, we are going to say, so this is going to be a redirection when I receive the traffic for HTTP, and I'm going to assign a listener. So the listener is secure front-end listener. So this is pretty smart the way they handled. This is actually a feature that was released last May or something. I just went through their history of this application gateway features. So this was a recent release. Otherwise, what they had to do was they had to transfer these requests to a backend pool, and from the backend pool they have to redirect back the user to the HTTPS. So this is sort of pretty smart that from the application gateway layer it handles the redirection. Okay, let's see that how it works. Now let me try that. So you can see it's been again, just inspect this. Okay, now you can see 301. So HTTP 301 means it's basically a redirect from HTTP, and the next call is HTTPS. So that's one thing. Okay, so there is one more one demo to be done. This is on about the routing, path-based routing, or what you call URL-based routing. I don't know whether the time I have enough time. It's already 4 past. Tarindu, what do you say? Shall I?
I think it's good to continue. So,
Okay, all right. Let me try to cover that up. That's the last one. So yeah, so this is what I'm trying to do here. Just try to understand when I receive a request. So I'm just receiving one request, and that request will basically travel. I will have images and video, 2 parts, and it will go to 2 different app ports. And there's a default one as well. For that, I will quickly go through, but I want to show you my implementation here. So there, I have 2 Azure web apps. I'm using apps for this, dev images and dev video. Just a very simple browser. It prints just simple message called images, and other one prints videos. Okay. Now for that, again, now I'm going to do having a special listener, because I have already occupied port 80 and 443 for HTTP and HTTPS. So I will have another different port to this. Let's say media listener. My front end IB is this, and I'm telling that I'm listening to the traffic on port 8080. Okay, this is going to be again the basic. And now let's see. I think I have the settings. No, I need to create the settings as well. I think I have the backend pools. No, not even that. Okay, let me quickly create the HTTP setting. Let's say video image server first. Image server setting. So this is going to be my video server, image server. So I'm just I have these URLs. So I'm telling that okay, override to this, and you can use a custom prop. Yes, the prop is there. I just assign that. Again, HTTP setting video server setting, and this time I will use the video override hide the host name to this, and I will use a custom probe, video server probe. Okay. So we have already assigned the settings and initial groundwork done. Now let's go to the backend pools and make sure that we don't have. So we are going to create the backend pools. Now let's say let's see if I can define. Let's see if I can go to the rules first. Okay, and see what happens. So now I'm going to have a rule called media rule. Okay, media listener, backend targets. Now, for this to work, let's see if I can use the backend. So for that, actually, I need to have a backend because now just forget about this section for a moment. I just need to highlight about the path-based rules, and I will go back to that again. So here, now I'm trying to use if a request arrives like this, let's say like this. Okay, it should go to the videos, and other one should go to the images. So I'm analyzing the URL path to make a judgment. So for that, you can say like this. Okay, if the path is images and the name of the, let's say image, this is just a name, don't worry about that. But this is important, your URL and the path, and setting is image server setting, target. Of course, you need to have a target. So I wasn't, I couldn't remember that, why I just didn't create it. Okay, let's quickly create two backend pools. Image server backend pool. So I'm going to have, this time you can see app service. I'm choosing. Okay, why is not image server backend pool? No. Basic rule. No, I haven't used that either. It should be front end backend pool. Yeah, it's there for that. This is strange. It is supposed to show this. Let me check my images because I use a free tier. It's running still. It's running. Status is running. Let me refresh. Okay, now it shows. I think because it didn't, I don't know, some browser issues, caching issue, something. Okay, now my backend pool is image server backend pool. So I'm going to use dev images, add it. And meanwhile, I'm using video. So backend pool. For that, I'm using dev video. Okay, so we added the backend pools. Now let's go back to the rule and we'll quickly create the rule. So my rule is media rule, and my listener is media listener. Targets. Now I'm quickly going through. This is the default. You might confuse why we are having another backend target. Why is that? So this is like, if you do not specify a path, what should do? Simple as that. So you can say by default I select image. Okay, so my simplicity. And now I'm going to create a path. Let's say if the path is like this, image, HTTP setting is image setting, and target is, this is the pool. And another rule for videos. Is it videos? Video server setting, backend pool. Yes, so we created another rule. Now what happens is, if you can remember our path, our URL, so we are going to initiate a call from this port. So this is my application gateway, port, and the endpoint. Now let's try to make a call. Let's see if it is saving. It's still saving. That's a problem. Yes. Yeah, so this is the last thing that I wanted to show. Deployment fail. Probably I was trying to do several things together. That's why it might get fail. But let's see if it fail again. I can retry. Usually, but what you have to understand what you have to understand here is that how path-based routing works. This is really important. That's the advantage of having layer 7 application layer routing, so that you have access to all this information. I think because this I'm using this free trial account, it probably they give me the most least priority to save my settings. That's why it take a lot of time to do even a simple update. Okay, one got succeeded. Let's refresh and see. Okay, is it the media listener? Media rule is there. Okay, it's there. Let's see if I can reach now. Cannot be found. 8080. Not. Something went wrong here, but I can't say exactly what's the reason. Yeah, but anyway, yeah, I don't want to drag this, beyond this. Actually, I tested this. This is something worked. Just to double check, custom probes and see video server probes test. Yeah, it succeeded. But anyway, let's not make the important is that how you are going to configure. I mean, there is no absolutely difference here about the configuration. So I think probably because we just got the that error, that's why it happened. But if we retry this, it will work definitely. So you can see the type, the routing type. So this is basic and this is path based. So I think I covered almost all the components in this. Okay, other thing is about the web application firewall. Otherwise, I missed the most important thing. So you can see that WAF here, the status is enabled, and mode is prevention, and rule set. So you can see the OWASP 3.0 is what I configured. So you can configure to whatever the version that you want. Here by default, all the rule set in 3.1 or 3.0, whatever thing you configured is applied, and including Microsoft Bot Manager rule set. But let's say if you want to specifically select some of them, you have to say, okay, advanced rule configuration, and you have to enable it, and thereafter you can select whatever the rule set that you want to apply. So by default, I just let it, because it's Microsoft did that for you, so it's easy for us to just simply follow. And so you can see the scale units and everything like that. Yeah, I think basically we were able to go through the application gateway, all the components. If you guys have any questions, please ask. I think there are people who have much more practically exposed to this tool. Yeah, so just ask anything that if it's not clear. All good? All understood? Right. I think that conclude the session. Yeah. So thank you very much for listening.